Look up at those fluffy white clouds drifting peacefully across the sky. They appear so light, almost ethereal, like puffs of cotton candy. But what if I told you that their serene appearance hides an astonishing secret about their true weight? Prepare to be amazed. A single, medium-sized cumulus cloud, the kind you see on a sunny day, can actually weigh over 1 million pounds. That's right, more than 1 million pounds, or roughly 550 metric tons. To put that into perspective, 550 tons is equivalent to the combined weight of about 100 adult African elephants. Imagine 100 elephants silently floating above your head. It completely changes how you view those innocent-looking clouds, doesn't it? So how can something so heavy stay airborne? The answer lies in its composition and the sheer volume of air it displaces. Clouds aren't solid objects. They are vast collections of microscopic water droplets or tiny ice crystals. These individual water droplets are incredibly small, typically ranging from 2 to 10 micrometers in diameter. To give you an idea, a human hair is about 50 micrometers thick. You literally cannot see them without a microscope. A typical cumulus cloud isn't just a small puff, it's a colossal structure. Picture a cube that's 1 kilometer wide, 1 kilometer deep, and 1 kilometer high. That's a huge volume of space for the droplets to spread out in. The key isn't how much water is in a small space, but how much water is suspended across an enormous volume. The density of liquid water within a cloud is incredibly low compared to a bucket of water. On average, a cubic meter of air within a cumulus cloud contains only about half a gram of liquid water. That's 0.5 grams per cubic meter. A minuscule amount. Almost imperceptible if you could reach out and grab it. Now for the math. A 1 cubic kilometer cloud contains 1 billion cubic meters of air. If each cubic meter holds 0.5 grams of water, then multiplying these numbers gives us the total water mass. So, 0.5 grams per cubic meter multiplied by 1 billion cubic meters equals 500 million grams of water. That's 500 million grams of water hidden within that seemingly fluffy cloud. Converting those grams into more understandable units, 500 million grams is equal to 500,000 kilograms. And 500,000 kilograms translates directly to over 1.1 million pounds. Suddenly, it all adds up. This staggering weight is entirely due to the water content. The air itself has weight too, but it's the suspended liquid water that accounts for the massive figures we're discussing. It's essentially a giant, floating reservoir. Now, you might wonder why something so heavy doesn't just plummet to Earth. The fundamental principle at play here is buoyancy. Clouds aren't lighter than the total air they occupy. They are buoyant within the surrounding atmosphere. Clouds float because the warm, moist air inside them, along with the water droplets, is less dense overall than the cooler, drier air surrounding them at the same altitude. It's like a giant, very slow-moving hot air balloon. As moist air rises from the ground, it cools. Eventually, it reaches its dew point, and the invisible water vapor condenses into visible liquid droplets. This forms the cloud base, which usually marks a specific temperature and altitude. An important factor in cloud buoyancy is latent heat. When water vapor condenses into liquid droplets, it releases a significant amount of latent heat. This warming makes the cloud air even more buoyant than its surroundings. This continuous release of latent heat within the cloud helps maintain its upward motion, preventing it from immediately falling. It's an ongoing process of condensation fueling the cloud's persistence and growth. Different types of clouds vary drastically in their weight. While a cumulus cloud is heavy, a towering cumulonimbus, or thunderstorm cloud, can be many times larger and contain far more water. A large cumulonimbus cloud can span several kilometers and reach altitudes of 12 kilometers or more. Such a storm cloud can hold hundreds of thousands of tons of water, potentially weighing billions of pounds. These huge atmospheric water reservoirs are crucial for Earth's water cycle. They store vast amounts of fresh water, transporting it across the globe before eventually releasing it as precipitation. Clouds aren't static entities, they are constantly evolving. Water droplets at the edges of a cloud are always evaporating back into vapor, causing the cloud to shrink or change shape. It's a dynamic balance. Meanwhile, new moist air flows into the cloud's updraft, condensing and adding more water droplets. This ongoing cycle of evaporation and condensation means the cloud's total weight is always fluctuating. Ultimately, when water droplets or ice crystals grow large enough, they overcome the updraft and fall as rain, snow, or hail. This is how clouds release their immense weight back to the Earth's surface. So, the next time you gaze up at the sky, remember that those seemingly lightweight puffs are actually gigantic aerial oceans, constantly moving and weighing millions of pounds, performing their vital role. Did you ever imagine clouds were so incredibly heavy? What aspect of their immense weight or floating ability surprised you the most? Drop your thoughts and questions in the comments section below. We love hearing from you. The science of meteorology is full of hidden wonders. Next time, we're diving into another common natural phenomenon with a surprising twist. Get ready to discover something unexpected about rainbows and their true form. If this video blew your mind with its surprising facts, please hit that like button to support our channel, and don't forget to subscribe for more amazing, Tell Me Why, science explainers every week.